Okay, so let's start the video. Let me start things up. Today we're just gonna be reading some docs and learning about Go channels, etc. Because in the last stream we saw that the next part of the HTTP course requires Go concepts, which it would be better to read about beforehand instead of just copying code and hoping stuff works. Uh, where's the what's the name of yeah boot.dev. Okay, boot.dev. And um, we have done this part already. We have done this part as well. We were at the last part, and before going to the last part, we need to learn about strings and runes. That's the first thing that we ought to do because the instructor is using strings and not like slices of bytes. So we need to. It's good to know about strings, especially when we're building uh, a text-based protocol. I don't know. I just feel like I should know. I should read this. Hmm. Okay. Strings are made of characters. In Go, the concept of a character is called a rune. So string is a sequence of runes, I guess. First, we're going to read this, and then we'll read that article. As is a string literal assigned a little value representing the word hello in Thai language. Okay. I'm gonna be talking less today because I'm also like having lunch while recording because I have a lot of stuff to do today, so I'm gonna have to eat while working. Mm, it's a character encoding standard used for electronic communication. We know that. Okay. Um, we have got lots of languages with lots of characters that computers should ideally display. Unicode assigns each character a unique number of code point. Okay. Hmm. Hmm. And try to cram the dominant language. And okay, okay. Um, okay. ISO 859 standards are the most common form of this mapping. Okay, okay. And but that's not enough when you want to represent characters for more than one language. So cramming all available characters into a single byte just won't work. There are essentially two different types of encodings. One that expands the value range by adding more bits, Okay, one expands the range by adding more bits. Okay. The other type of encoding uses a variable number of bytes per character. Okay. Okay. Mm, I don't get this. I don't get this. Um, okay, so if you have a fixed number of bytes, you have a limited number of characters that you can display. What doesn't make sense to me is that isn't 4 bytes enough? It sounds like a lot. I get that the variable number of bytes per character would increase the number of character, number of available mappings, but I don't think there's much of a difference. Yeah, it is actually. But it's a 2x difference, I think. Yeah, it's a 2x difference. Am I wrong? Um, let's just come on, man. Why won't you run? Yeah, Python 3 and um, 2 power 8 plus 2 power 16 plus 2 24. So there is a big difference. Okay, okay. I was thinking along the wrong lines when I said 2x. Okay. Hmm. So there is a 255x difference. I don't know. Uh, Variable number of bytes per character. Most commonly known encodings for this are the UTF encodings. All UTF encodings work in roughly the same manner. You choose a unit size, which for UTF-8 is 8 bits and UTF-16 is 16 bits and 32 bits for UTF-32. Okay. The standard then defines a few of these bytes as flags. If they are set, then the next unit in a sequence of bits is to be considered part of the same character. If they are not set, this unit represents the character fully. Okay, thus the most common English characters occupy only 1 byte in UTF-8, but other language characters can occupy 6 bytes or more. That's what I said. Like they check the first byte, and based on the first byte, based on the output of a function that accepts the first byte, you get to know whether or not you should consider the next byte as part of the same character. I was calling it passing logic in the last scene. Yeah, multi-byte encodings have the advantage that they are relatively space efficient. Yeah, but the downside that operations such as finding substrings, comparisons, etc., all have to decode characters to Unicode code points before such operations can be performed. So Unicode, I didn't get what Unicode is from here. Both UCS standards and UTF standards encode the code points as defined in Unicode. Okay, so Unicode is a mapping of numbers to different characters, and UTF-8, UTF-16, ASCII, UCS are different ways of representing those numbers in binary. Okay, HTTP tends to work best with UTF-8. This may be important for us. Okay, yeah, it makes sense. Um, and that's why we were reading in terms of bytes. Maybe that's why we were supposed to make a byte slice, a slice of bytes. I know. Mm, uh, Ghost string letters are UTF-8 encoded text. Okay, okay. So UTF-8 is the variable length encoding thing. Okay. Since strings are equivalent to a byte uh, slice, this will produce the length of the raw bytes stored within. Okay, okay. Indexing into a string produces the raw byte values at each index. Okay. Hmm. When we want to count the number of UTF-8 characters, we don't want to count the number of bytes. We use the UTF-8 package. Okay, so we have a Unicode slash UTF-8 package, and you use it round count in string s. I was expecting a string to have like a s dot something, but maybe like Golang doesn't want you to think in terms of objects, and that's why it only allows you to do this dot thing, this method like syntax for packages. I don't know, like this is more like a kind of like a namespace instead of uh, a method like syntax or something related to ah hmm. Note that the runtime of rune count in string depends on the size of the string because it has to decode each UTF-8 rune sequentially. Okay, some Thai characters are represented by UTF-8 code points that can span multiple bytes, so the result of this count may be surprising. Okay, so this kind of thing actually makes sense. Like if I am reading a file which is encoded as UTF-16 or whatever. Like I would want to, before printing it, I would want it to be decoded by UTF-16 and stuff. Like strings shouldn't have like all these methods for all types of encoding and stuff. Whenever a new encoding scheme arrives, just another library, just another package will be created, and you can like code that has already been written, like the string pack, the implementation of string in Go won't get modified. Whenever a new character encoding scheme comes, you'll the people who maintain the Go language will just add another package, and you'll be able to use it like this. I think it's called dependency inversion principle. This sort of design is known as. Okay, so note that the runtime of rune count in string depends on size of string. We have already read this. Some Thai characters are represented by UTF-8 code points that can span multiple bytes. So the result of this count may be some surprising. Okay. Then you have a range loop that handles strings specially and decodes each rune along with its offset in the string. Now, what I said before, this thing just obliterates it. No, maybe it doesn't. No, no, it doesn't. Like by default, Go uses UTF-8 because it's popular, and this guy also uses UTF-8 because runes are UTF-8 characters. A character, maybe not. I don't get it, man. I need to read more about runes. Using decode rune in string. By default, you'll get like this UTF-8 thing, and then if you don't, let me think. Yeah, so you have a sequence of bytes. We don't know what the sequence of bytes is encoded as. So to get a rune, you need to make an assumption about what sort of encoding scheme is the string using. And based on this sentence, runes are UTF-8 characters. Okay, so by default you index the string as UTF-8 string like this, and if you want to use a specific encoding scheme to interpret the sequence of bytes, you import a package and you use like the decode rune in string method. Okay, for I comma w equals 0. Guys, let me come back. Just a second. अब ये वीडियो मैं YouTube से कोई नहीं हटाने लगा, पूरी दुनिया को अब पता चलेगा कि आप शायद एडिट हो जाए, लेकिन हाँ शायद हो जाए. Okay, I'm back. Uh, where were we? So we were looking at this loop. Okay. Um, for I comma w, both are declared and initialized with 0. Okay, okay, okay. Yeah, yeah. I is less than len and I plus equals to w, and we will be setting w inside the loop when we do this thing. Yeah, w equal width. I told you, man. Okay. So fmd dot print f. Okay, what's this guy, man? We need to know. Uh, docs standard library, I guess. No, go spec. Go spec. Okay, we can get the, yeah, we don't need the ghost spec. Oh my god, this ghost spec is long, man. Okay, so yeah, this is the whole of the ghost spec. Wow, it's not that long, but we need to right now we need the standard library. We don't need to read the ghost spec. This may be helpful when we're like building the compiler thing. I hope we get around to doing that. Uh, so you have capital U, Unicode format. Okay, same as mm, right. Let's just copy paste this code and see how it runs. cd scratchpad l cd http clear l touch test.go vim test.go, and this is it, and import fmt, import, I think it was this. Oh, you have a nice syntax for multiple imports. You don't have to write imports again and again. Unicode slash UTF, and oh man, I hate like WSL. Like, whenever I do like this, I'm clicking H right now, which means for go one character left. It produces this weird sound when I'm at the start of a line. I hate it, man. Like in Vim, in Linux, this doesn't happen. Um, so you have a string. I'll just copy this string. Yeah, this passes demonstrates passing a root value to a function. This is it isn't anything awesome. Rune value comma width equals decode rune in string. So it's decode rune in string. It just starts from the start of the slice, and it just keeps reading until it that's a complete rune. Okay, 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 okay. Yeah, and this should print. So this thing gets printed when you are using like when you're using like this decode rune in string. I'm sorry, like this thing, percentage hash capital U. Do we have a hash in printf? Because they said their print line is inspired by printf, fmd.println. Yeah, hash. So it's a flag. The value should be converted to an alternate form, like in Go. For O conversions, the first character. Okay, it's similar to how it's in C. Okay, okay, okay. So we removed rmtest.go, and we don't want need to examine this rune and values and closing single quotes are rune literals. We can compare a rune value to a rune literal directly. I think we have had enough of strings and runes. Maybe we'll read this blog post. Uh, yeah. Um. Uh. Okay. At first, strings might seem too simple a topic for a blog post, but to use them well requires understanding not only how they work, but also the difference between a byte, a character, and a rune. The difference between Unicode and UTF-8, which was something I was confused by. The difference between a string and a string literal, and even more subtle differences. One way to approach this topic is to think of it as an answer to the frequently asked question: when I index a ghosting at position n, why don't I get the nth character? As you'll see, this question leads us to many details about how text works in the modern world. Okay. So the nice thing about Go is it doesn't hide all this complexity behind, an abstraction. It shows us that if you want the nth character, it's gonna take O of n time. Okay, that's just it. They don't hide it uh, like in Python. I think Python does hide it. I don't remember. Yeah. What is a string? Let's start with the basics. In Go, a string is in effect a read-only slice of bytes. If you are at all uncertain about what a slice of bytes is or how it works, blah 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 blah. It's important to state right up front that a string holds arbitrary bytes. It's not required to hold Unicode text, UTF-8 text, or any other predefined format. That's super cool. Because if a new encoding scheme comes, you don't have to like. I've talked about this before. That why uh, decode as UTF-8 method is in a package, and why that's a good thing. Dependency inversion principle. Um, it's not required to hold Unicode. Blah 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 blah. Um, yes, yes, yes. Here's a string little that uses the backslash x and n notation. I think this is the hex notation. Yeah. Okay. Printing strings. Some of these bytes in a sample string are not valid as ASCII, not even valid UTF-8. Printing the string will produce ugly output. The simple print statement produces this mess. To find out what this string really holds, we need to take it apart and examine the pieces. There are several ways to do this. The most obvious is to remove its contents and pull out the bytes individually, as in this volume. You have a percent %x. What is percent %x doing? Percent %x. Base 16, lowercase 2 characters per byte. Base 16, lowercase 2 characters per byte. So it's printing the base 16 lowercase. Okay. So it's printing the hex value that is stored in the byte. Okay. Uh, okay. Yeah. Notice how the individual bytes match the hexadecimal escapes that define the string. Mm, 1, 2. Okay, it's saying like here's BD, here's BD. The second thing is like B2, it's B2. So it's saying that this escaping thing is working. It's being interpreted as a hex due to the backslash x. Okay. A nice trick is to use the space flag in the format. Mm, a shorter way to generate presentable output for a messy string is to use the backslash percentage x format verb of printf. It just dumps out the sequential bytes of the string as hexadecimal digits 2 per byte. Yeah, we know this. Compare its output to that above. They had a space. Why isn't it being printed in a pretty way? I don't know. I think it should be printed prettily. Touch test.go, vim test.go, package main import, uh, fmt func main, shit, you, and you have a sample which is equals to this guy. Let's just copy this entire statement and let's just run this guy. There should be spaces. Yeah, there should be spaces. No, there's a mistake in the docs. Let's run this one. Oh my god, what the hell is happening here? So, what the hell is happening? Okay, so we're printing sample again and again. Okay, so I am fmd.printf. Um, guys, wait a minute. I need a second to do something. I'll be back. Okay, where were we? Okay, that's what they were talking about. Uh, okay, there isn't a mistake. Okay, a nice trick is to use the space flag in that format by putting a space between the percentage and the x. We also have this guy in printf. I think it's in the flags. Yeah, we can also. I can also show this to you. Uh, test.c quit and l rm ls minus a rm dot test rmt touch test dot c vim test dot c uh, smaller than I plus plus. We know it's the size of car is one, but I just want to write it. Printf. Yeah. Uh, okay, there is something wrong here, and I also need to put in my charger. Uh, let's use it with percent %x. I think maybe you can't use space with C. Let me read the man page again. Let's first put my charger. Yep. And uh, man printf dot 3. Yeah. A blank should be left before a positive number or empty string produced by a signed conversion. So we need to have either an empty string or a positive number. So a positive number can be gotten only through these sort of things, but sorry, these sort of things. And I want x. Where is x? Yep. X. Uh, X is for unsigned hex notation. And तुम इधर ही थे ना अभी पिछले 1 घंटे से इधर ही हो नहीं यार वीडियो चल रही है नहीं आया I don't know what's going on here. Flag used with %x GNU printf format. Why is it a warning in here and not in here? What am I doing wrong? Maybe let's just try um, maybe we don't need to put a character here, we need to put Uh, so you need an I need my character to be read as a hex. Let's go again. Uh, man, printf.c. Ugh. Mm, it did say above that we can use space with a blank should be left before a positive number produced by a signed conversion. So maybe we need to do we are doing a conversion. We're taking an unsigned int argument and converting it into an unsigned hex. What is wrong here? Maybe we need a signed number. But then how will we represent it as a hex? I don't know. Let's just Google it. Printf %x. Yup. The space flag is used with numeric format specifiers. Let's try %d. Let's try %d. Um, okay, so we're getting the spaces. Man print f. So apparently we can't get a space for unsigned in numbers, unsigned numeric values. I don't know why, but we can't get them. Maybe we can get a signed hex. Do we have signed hexes? Uh, I don't know. It's actually good that Go improved this. This was worth improving, in my opinion. Uh, I think I will have to end the stream in a few minutes. Let me check uh, what time I have to go. Um, I have to go at. Okay, so Yeah, I'm gonna end this in like a minute. Then maybe I'll come back after like half an hour again. Um, yeah, let's end this. Let's end the stream. I'll probably